Welcome, math adventurers! Today we're learning about expressions and numerical operations. By the end of this lesson, you'll understand the key ideas behind this topic and how they work together in algebra. Think of algebra like training for a tournament. Numbers are your basic moves, operations are how those moves combine, and expressions are short math recipes. Once you can read the recipe, you can understand what the math is trying to do. A numerical operation is an action we do to numbers. Addition joins amounts. Subtraction finds what is left or the difference. Multiplication makes equal groups. Division splits into equal groups or finds how many groups fit. Here is the important idea: operations tell a story. If a snack pack has 4 rows with 6 crackers in each row, 4 times 6 describes equal groups. If 24 crackers are shared by 3 friends, 24 divided by 3 describes a fair split. Algebra uses the same actions, but sometimes one number is not known yet. Expressions can use many kinds of numbers, not just counting numbers. Negative numbers show values below 0, like a temperature of -4 degrees or a game score that loses points. Fractions and decimals show parts of a whole. 1/2, 0.5, and 50% can describe the same amount in different forms. When these numbers appear in expressions, the operations still mean the same thing. -3 plus 8 moves up 8 from -3 and lands at 5. 1/2 times 10 means half of 10, which is 5. A decimal like 2.5 plus x means a starting amount of 2.5, then an unknown amount added on. Algebra works with all these number types because the rules of operation stay consistent. When an expression has more than one operation, we need a fair order. Parentheses come first because they are the closest instructions. Exponents come next when they appear. Then multiplication and division move from left to right. Finally, addition and subtraction move from left to right. Watch this expression: 3 plus 2 times 5. If we add first, we get 25, but that changes the recipe. Multiplication has priority here, so 2 times 5 becomes 10, and 3 plus 10 becomes 13. The order keeps every reader on the same path. An expression can include a variable, which is a symbol for a number that can change, or a number we do not know yet. In 4 times plus 7, the variable is x. The 4 is the coefficient because it multiplies the variable. The 7 is a constant because it stays the same. The pieces separated by plus or minus signs are called terms. So 4 times and 7 are the 2 terms. Reading these parts is like reading a character stat card. Variable, coefficient, constant, and terms all tell us what the expression is made of. Two expressions are equivalent if they always have the same value, even if they look different. Think of equivalent expressions as 2 training moves that reach the same result. The expression x plus x is equivalent to 3 times, because it means 3 copies of x. The expression 5 plus x is equivalent to x plus 5, because addition can switch order without changing the total. Equivalent does not mean the expressions have the same symbols in the same order. It means they produce the same output for every value of the variable. If x is 4, then x plus x gives 12, and 3 times also gives 12. If x is 10, both give 30. This idea is important, because simplifying an expression is really changing it into a cleaner equivalent expression. To evaluate an expression, replace the variable with a number, then follow the order of operations. If x equals 3, the expression 4 times plus 7 becomes 4 times 3 plus 7. Multiplication happens first, so it becomes 12 plus 7, which is 19. Expressions can also come from words. The phrase 5 more than a number becomes n plus 5. 3 times a number becomes 3n. 2 less than a number becomes n minus 2. The words describe the math recipe, and the expression records it clearly. Algebra also has properties that let us rewrite expressions without changing their value. The commutative property says addition or multiplication can swap order. 2 plus 5 equals 5 plus 2. The associative property says grouping can change for addition or multiplication. The distributive property spreads multiplication across a group. 3 times x plus 2 becomes 3 times plus 6. Then we combine like terms, which are terms with the same variable part. 2 times plus 5 times becomes 7 times. Like terms can team up. Unlike terms stay separate. Great job learning about expressions and numerical operations. You've taken another step toward mastering algebra. Thank you for watching, and I'll see you in the next lesson.